let us detailedly discuss two terms, very important terms actually. One is empirical formula, the other one is molecular formula. It's empirical formula and the molecular formula. In the initial phase, we will define it. The next part, we will do some problems related to those calculations. Let's do. So, what is empirical formula? Empirical formula can be defined as, it is the simplest whole number ratio of atoms of various elements which combines to form a single molecule of a compound. Let's understand easily. Let's take an example. What is glucose formula? Glucose formula is C6H12O6. This is glucose, right? Glucose has three elements in it. One is carbon, the other one is hydrogen, the other one is oxygen. Carbon, hydrogen and oxygen combines in a specific ratio to form glucose. You know that there is number of compounds in which there is carbon, hydrogen and oxygen. But what makes glucose is its composition. C6H12O6 is always glucose, fructose also. But basically speaking, this is unique, right? You know that glucose has already three elements: carbon, hydrogen, oxygen. You can divide, you know that in this the common factor is 6. 6 can be, so you can divide the entire equation by 6. So we get CH2O. This is actually the empirical formula of glucose. So if you divide the normal formula, that is actually molecular formula. If you divide the normal molecular formula by the common factor, you will get the empirical formula. Simple, right? So empirical formula is the simplest ratio by which atoms of different elements combine. What is the ratio? 1:2, 2:1. That is the ratio of combination of atoms of different elements. In case of glucose, one carbon will combine with two hydrogen, in turn combine with one oxygen. That is the empirical ratio. Okay. Then the next is molecular formula. That is the normal formula, the actual formula, true formula. That is molecular formula. It states the complete formula of a particular compound. Molecular formula of glucose is C6H12O6. That is the actual one. By saying the molecular formula, we can say which is it. That is unique. Molecular formula is unique for a particular compound. You know that molecular formula of ethene, ethene, okay, it has a double bond, that is C2H2. Sorry, C2H4. That is the molecular formula of ethene. Okay, if it was ethine, it will be C2H2. This is ethene, C2H4. You know that is propene. Propene is C3H6. That is propene. This is ethene. Ethene can be written like, you have two carbon atoms. This is actually ethene joined with a double bond. That is CH2, CH2. This is ethene. The propene is having a single double bond with three carbon atoms. That is actually CH2 double bond CH single bond CH3. You look, 3 carbon atom and 6 hydrogen atoms. This is propene. So ethene's molecular formula is C2H4 and propene's molecular formula is C3H6. So what about their empirical formula? You know that empirical formula you will get when you divide the molecular formula by the common factor. In C2H4 the common factor is 2. So you can divide this by 2, so you get CH2. That is the empirical formula for ethene. What about propene? In case of propene, the common factor is 3. So you are dividing it by 3, which in turn you will get CH2. So you see that for both ethene and propene, the empirical formula is same. And number of compounds, the empirical formulas will be same. But the molecular formula differs in compound by compound, which is actually the identity, right? You know that the government issue Aadhaar cards. Each individual have different Aadhaar card, right? Which is his identity, his own identity. Similarly, the molecular formula is an identity of a particular molecule. You can call methane, benzene. So everything is different. But different molecules may have same empirical formula because it is simplest ratio only. Empirical formula is the simplest ratio by which the elements combine. Okay? Let us look some further examples to detailedly understand empirical and molecular formula. What is the molecular formula of benzene? In case of benzene, the molecular formula is C6H6, right? This is benzene. It's an aromatic compound, right? In which there is delocalization of electrons. So this is benzene. The molecular formula is C6H6. What will be the empirical formula? You can divide it by the common factor 6. You will get empirical formula CH. Okay, this is empirical formula of benzene. The same case, you can take ethine, ethine, which have a triple bond. It is C2H2. This is ethine. The empirical formula is of ethane is also CH. So, as already mentioned, the empirical formula of two different compounds, benzene and ethane, is same. But obviously, their molecular formulas are different. So, you can understand that empirical formula is the simplest whole number ratio by which atoms of different elements combine. You know that CH, this is CH. You can multiply with N. Let's take another example. Let it be hydrogen peroxide, that is H2O2. This is hydrogen peroxide. It is known as peroxide due to the presence of peroxide linkage, that is oxygen-oxygen linkage. This is actually the structure of hydrogen peroxide. That is a open book structure. This is the structure of hydrogen peroxide. It's like this, here with 2 oxygen. And the other part you have hydrogens like this. So this is the structure of hydrogen peroxide. It has a peroxide linkage, oxygen-oxygen linkage. So you know this is the actual molecular formula of hydrogen peroxide. What will be the empirical formula? You can divide it by the common factor 2, you get HO. So HO is the empirical formula of hydrogen peroxide. So now you can easily find the empirical formula if you know the molecular formula. You can simply divide it by the common factor. Now let us take another compound. Let it be KClO3. Okay. This is the molecular formula. KClO3. In this case, you know that empirical formula is also same because potassium 1:1:3. This is the simplest ratio. So in this question, the empirical formula is also KClO3. So in certain cases, empirical formula can be equal to molecular formula. But usually you can divide it by a common factor. And however, once you divide it by the common factor, if you are getting it like the ratio, let it be 1:1.5 let it be 2. So what you have to do, if the ratio is like that, you have to multiply it with a common factor to make it into a whole number. So you can divide it into 2, you will get 2:3:4. So the ratio must be in the whole number. So I will again define empirical formula as the simplest whole number ratio in which the atoms of various elements combine. And the molecular formula is the true actual formula of any molecule, which is unique, the identity of a compound. Okay. Now let us look at a question which helps us to predict the empirical formula. The question will be given like this. An inorganic salt has the following composition. The composition in which there is actually this salt is having 3 elements. One is sodium, the other one is sulfur, and the other one is oxygen. And they are giving its percentage composition. Out of 100%, nearly 29% is sodium, nearly 40.5% is sulfur, and 30.3% is oxygen. So the question is asking us to calculate the empirical formula. So based on this data, we have to find the empirical formula of this compound. Let's look. So doing these problems, we have a particular technique. The initial thing is that you first of all write the elements. You write what all are the elements provided. The elements are sodium, sulfur, oxygen. 3 elements. Okay. And they are providing you the percentage. Sometimes in the question they won't be providing you the percentage of a particular element. They may give the oxygen is X%. So how to find the oxygen percentage? Find it how you can 100% is the net one. So you can minus sodium is 29 plus sulfur is 40. So it will be like 100 minus it will be 69. You will get approximately 31%, right? So you can do this calculation. If the one of the elements percentage is not given, from the others we can find. So easy only. So in some questions you won't be given the percentage of every elements. So you can use this technique to find the percentage. So we have wrote sodium, sulfur and oxygen. In the next part you make it as like a column and you do the question. In the next part you can write the percentage composition. Initially you wrote the elements, then we will write its respective percentage composition. Here it is 29.11, right? In the next part of sulfur it is 40.51, and in case of oxygen unit is 30.38. We wrote the percentage. Now you divide these percentages with their molar mass. You divide it with their molar mass. So you know, in the case of sodium, its mass is 23, right? Sulfur it is 32, oxygen it is 16. Okay, we are dividing it with their atomic or molar mass, whatever it means. It's in gram means you have to divide it with molar mass. If it is given in U, you can divide it with atomic mass, but the value is same only, the unit only changing, no issues. So here I am dividing the 29.11 by 23, 40.51 by 32 and 30.38 divided by 16, right? Once you divide it, you will get here like 1.26. Yeah, here also you will get 1.26. Here it will be something nearly 1.9 you will get. Okay, you are dividing this and you are getting the respective values. Now you divide these three values by any of the one which is least in value. I will tell you. Here 1.26 has the least value compared to 1.9. So you divide the 3 by 1.26. Say that you are getting in this column, you are getting like 3, 4 and 5. So what you should do? You have to divide 3 by 3, 4 by 3, 5 by 3. You are dividing the rest by the one which is in least. Okay. So here it is 1.26. So we are dividing it by 1.26 because that is the least one among them. So you will get 1. Here also 1. Here it is, I will write 1.26 by 1.26. Which is 1. Here 1.26 divided by 1.26, which is again 1. It is 1.9 divided by 1.26, which is nearly 1.5. Okay, so you got the ratio, that is sodium is to sulfur is to oxygen ratio is 1 is to 1.5. But I said the empirical formula has to be in the simple whole number ratio. 1.5 is not a whole number. So you multiply it with 2 to make a whole number. So you get 2 is to 3. So what is the empirical formula? Na2S2O3. You got it? So this type of questions are sure. So all these questions have same method to proceed. Initially you write the elements, then you write its given percentage composition. Now you divide with their respective molar masses. You will get some values. Pick up the value, least value among them. So divide all the three or all of them by the least value, and so you will get a ratio. Make it into the whole number ratio and multiply it with the. So let us look the next question. In the question you are given the percentage of hydrogen, carbon, chlorine. So three elements you have. One is hydrogen, other one is carbon, the other one is chlorine. Okay. And you are given the molar mass also. The last question was not given anything. Only you are given with the percentage composition and you are asked to find empirical formula. Here you are given with molecular mass also. So you can easily understand that a molar mass is given for finding molecular formula. Okay. So first of all, let us find empirical formula. Normal method. How to do? First of all, write down the elements given provided in the question. Write their corresponding percentages. Like the first one is carbon, that is 4, right? It is 4.07%. That is hydrogen. Next one is carbon, that is 24.27. No need to put the percentage right now. And chlorine is 71.65. Now what was the second step? Dividing their percentages with their respective atomic or molar masses. So in case of hydrogen, divided with hydrogen, you know the molar mass is 1. In case of carbon, it is 12. Chlorine is 35.5. So you divide it with their respective molar masses. So 4 by, actually let us eliminate the decimals. So hydrogen 4 by 1 you will get 4. In case of carbon 24 by 12 you will get approximately 2. In case of chlorine 71 divided by 35.5 you will get 2. Okay. Now the next step is to divide these by their simplest or the least value. Least value is 2. So divide it by 2, the 4 by 2, 2 by 2, 2 by 2. So here you will get 2, here you will get 1, here you will get 1. Okay. So the ratio of hydrogen is to carbon is to chlorine is 2 is to 1 is to 1. So it will be C. Basically we can write it like H2CCl. I can write it CH2Cl. Okay. So this is the empirical formula. So let us find empirical formula mass. That is the mass of this compound. That is empirical formula mass. The mass of empirical formula is empirical formula mass. Okay. So what will be the mass? 12 of carbon, 2 hydrogen plus a chlorine, 35.5. So it can be 35.5, 37.5, 49.5. Right. This is the empirical formula mass. Let it be in gram. Okay. It is given in molecular mass, given in gram. So empirical formula mass can be written in gram. Okay. Now find its molecular formula. How to find its molecular formula? Empirical formula into n factor. We already said empirical formula into n is molecular formula. Okay. So you have to find n. How to find n? So n is actually molecular formula mass by empirical formula mass. N factor is molecular formula mass by empirical formula mass. Note. So n factor is molecular formula mass by empirical formula mass. You know molecular formula mass is given in the question. This is molecular formula mass. So 99 divided by empirical formula mass, that is 49.5, which is simply 2. N factor is 2. So you can put n factor as 2. So you can get the molecular formula as C2H4Cl2. Okay. So once you get the n factor, you multiply it with the empirical formula, you will get the molecular formula. Okay. But some questions, instead of molar mass, you may be provided with vapor density. Okay, no issues. If vapor density is provided, we can multiply it with 2 to get molar mass. That is the actual molecular mass of the compound. To find the actual molecular mass, you can multiply vapor density into 2. So say that vapor density given in the question is, for another example, let the vapor density be 30. So you can just multiply it with 2. So the molecular or molar mass will be 60. So vapor density into 2, you will get the molecular mass. Okay. So you have studied in today's lecture what is empirical formula, what is molecular formula, what is empirical formula mass, what is molecular formula mass, how to find those when the percentage composition is given, then how to convert vapor density into molecular mass. Okay. Thank you.